All right, for today's lesson, we're going to keep going with our inverse trig, and today we're going to be focusing on tangent for inverse trig. And it's basically the same thing as we were doing with sine and cosine. We're just using tangent now. So for the first one, again, we are finding angles here instead of side lengths. So we are missing this angle theta right here in the corner. And then I'm going to label the side opposite of that. And then this 13 is the side adjacent. So if we were using SOHCAHTOA and you weren't sure what to use, I got opposite, I got adjacent, opposite, adjacent, go with tangent. So that's how I know to set up a tangent function. So I'm going to tan of my angle, which happens to be theta here, equals my opposite over my adjacent. And now in order to get that theta by itself, that's where I do the opposite of tan, and that would be that tan inverse, or tan to the -1. We tan inverse this side. We do theta equals tan inverse of 9/13. And then we grab a calculator, Desmos calculator. So again, in order to get there, I'm going to go function and then tan inverse of 9/13. And that gives us 34.7. So our theta equals 34.7 degrees. Next one, it says find angle A. So angle A is in this corner. So that's my highlighted angle. And then I'm going to go opposite of that angle and again adjacent to that angle. So again, because I have opposite adjacent, that goes with T for tan. So tangent of A, I'm looking for, that's my angle, equals opposite over adjacent. Again, we have to get rid of tan to get that A by itself. So I'm going to tan inverse both sides. So then I'm left with A equals tan inverse of 20/25 equals, grab a calculator, tan inverse of 20/25, it's going to be 38.7. So theta equal, or A equals 38.7 degrees. For the next one, find angle A again. Now angle A is in this top corner over here. So then I have basically all the side lengths that I can use. So it's kind of up to you to decide. I don't have to use tangent here. I could use like sine, cosine, doesn't matter. So this is my opposite. And then if we want to use tan, this would be our adjacent. We could use sine and do the hypotenuse. We kind of have our options here open. And you should get the same thing if you're setting up your ratio correctly. But if I'm using opposite over adjacent again, that's just going to be tangent. Tangent of A equals my opposite over my adjacent. Again, we do tan inverse to get rid of that tan. So we get A equals tan inverse of 12/5. Let's see what that is. Tan inverse of 12/5. That's 67.4. So A equals 67.4 degrees. And then our last one, right angle or right triangle ABC is drawn. So I'm going to draw a right triangle. The right angle located at A with side length BC as the hypotenuse. AB is 8, BC is 10, and then CA is 6. What is the approximate angle measure at C? All right, so then if I want to find C here, again, I kind of have my pick right now. I can choose whatever I want to do. So if I choose opposite, and then maybe let's change it up. Maybe I want to use my hypotenuse over here. So opposite hypotenuse, if I look at my SOHCAHTOA, then opposite hypotenuse, I can use sine, that S. So I can set this up as sine of my angle C equals opposite over hypotenuse. And then again, now I want to get rid of my sine, so I just sine inverse it. Instead of tan inverse, sine inverse. So I get C equals sine inverse of 8/10. So sine inverse of 8/10. And I get 53.1. Now, if we wanted to do tangent would have been opposite over adjacent. So let's see if we would have got the same thing. So 8/6. So tan inverse of 8/6 and see how you would have got the same thing. So you can set this up. As long as you're setting up your ratio correctly, you should get the same thing regardless.